All right, guys. So we're actually going to finish up the notes. We got two more examples and then you're all done. So this one is the linear factorization theorem. This basically is for when they give you your zeros. And then you also have to fulfill the requirement of plugging a value into the function. So they're saying at f of 1, your function should be 8. So how does this work? So if we got -3, that means we had to have x plus 3, because when you set that equal to 0, subtract 3, x is -3. That should totally be an I, by the way. That's an I. Now I will tell you, imaginary always comes in conjugates. So if you got I, you also had -I. So we're going to put x plus I and x minus I. Again, those imaginary answers always come in conjugates. So you are going to have both of those. All right, so there's your function right now. Now that doesn't look very user-friendly, so we're going to go ahead and distribute everything out. So I'm going to do those conjugates first because they'll be nice. X times x is x squared. And then I times -I is -I squared, which remember, -I squared. I squared is -1, so really you have the opposite of -1, which is +1. Let's go ahead and FOIL this out. X times x squared is x cubed. 3 times x squared is 3x squared. X times 1 is x, and 3 times 1 is 3. So here's the only issue, is this could be multiplied by something, right? And that's where this a of n comes into play. I guess I should have been writing that. We're going to add it in front here. So we have the main gist, but we have to find out if there's anything that's being multiplied by all of this. So any multiples. So this is where your answer comes in. We need our function at 1 to equal 8. So let's go ahead and plug that in. But we really like this function right now. We're going to box this in so that we know to come back here. All right. So if we plug in 1 cubed, 1 squared, 1, and 3. So we plugged in 1, and we want that to come out as an 8. Okay. So we've got 1 squared is 1 times 3 is 3, plus 1 plus 3. So what do we have? A sub n times 8. So to get a sub n alone, we're going to divide both sides by 8. We know a sub n is 1, which means we're multiplying this by 1. So really we have 1 times all that stuff. So in this one, it didn't really, finding a sub n didn't really do much because our function is exactly what we had in the first place. However, sometimes a sub n is a different value. Like if it was 2, you'd have to distribute that 2 to get your final function. But just, work your way through it. Okay, work your way through it. Remember imaginaries. You're always going to have the imaginary number and the conjugate. All right. And then the last one is Descartes' rule of signs. So Descartes' rule of signs would have been really, really, really beneficial to know in the first part. So what this rule tells you is it tells you about your roots and how many you could potentially have, how many positive and how many negative. And it's all based on, it's called the rule of signs because you're looking at the signs. So you're looking at your signs to change, and that's what you're counting is how many sign changes. So we go from positive to negative. There's 1 sign change. There's 2 sign change. 3, 4. So we actually have 4 sign changes. which means for positive real roots, we could have 4 of them, or less than that by an even amount. So we could have 2 of them, or we could have none of them. So you either have 4 positive real roots, 2 positive real roots, or none at all. So that doesn't help us that much. Now the negative real roots, you want to find your function at negative x. So let's go ahead and plug that in, negative x to the 4th, 14, negative x cubed, 71, negative x squared, 154 times negative x, and 120. So let's simplify this down. Negative x to the 4th is just x to the 4th, right? Becomes positive. Negative x cubed is negative x cubed times negative 14 becomes positive 14x cubed, right? Because a negative times a negative gets me a positive. Negative x squared times 71 is 71x squared. Negative times a negative makes a positive 154x. That's a 4. And plus 120. So if we're looking here, positive, 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 there are 0 sign changes. 0 sign changes. So what does that mean? All right, what does that mean? That means your negative real roots, you have none. So there's no negative real roots. There's no negative real roots. My bad. I missed. And you could have either 4, 2, or 0 positive real roots. So how could this have helped us in the beginning? Think about it. We would have had all those plus or minus for 120. 1, 2, 3, 4, 5. You would have had so many of them, right? Plus or minus. Well, this tells me that I have no negative roots, which means it would eliminate half of your possibilities. It would eliminate half of your possibilities because you know there's no real negative roots. So all those negative roots, when you set it up, all those negative roots, you could have just eliminated them and not even tried to do your synthetic division. So if you think back to the beginning, we wouldn't have had to use synthetic division on all those negative numbers here. All right, that's it for today, guys. Get your homework done.